So let's have a look at the wording of the question. If the sample mean is 75, sample standard deviation is 24, and n is 36, and assuming that the population is normally distributed, construct a 95% confidence interval to estimate the population mean mu. Okay, so we know we're going to do a confidence interval. We know it's going to be a 95% confidence interval, and it's in relation to the mean. Straight away, when we're looking at confidence intervals for the mean, we know we have to think about whether we have sigma or whether sigma is unknown. Now, if we summarize the values that we've got in this question, we've been given the sample mean 75, sample standard deviation is 24, sample size 36, and we know it's a 95% confidence interval. Now, the fact that we don't have sigma and we only have S tells us straight away that we're going to be using the t distribution for this confidence interval. So it's still going to be the same types of steps that we went through in problem 8.8. The main thing to realize is that this is an example where sigma is unknown, and therefore we're going to use the t distribution. I still like to start by drawing up my diagram and finding the critical value that will be used in the confidence interval formula. You might find that, well, another alternative is to write down the formula first and let that remind you. We can see that certainly the formula is still point estimate plus or minus critical value times standard error. It just so happens that here our point estimate is the sample mean, x bar. Our critical value is t, and our standard error is s over the square root of n. So we don't have sigma, we use s, the sample standard deviation, instead. Now we must get the t value. We need to know the critical value that goes into the formula. I draw up my diagram. It's a 95% confidence interval, so I've got 95% in the middle of the diagram, 5% left over, but it's split between the two tails. Each tail is 2.5%, and it's the upper tail of 2.5% that I can use in the t-tables to get my critical value, the cutoff point. Now remember, with a t distribution, we need to know the degrees of freedom. Degrees of freedom, when we're looking at confidence intervals for the mean, where sigma is unknown, degrees of freedom for the t distribution will be n minus 1. Our sample size is 36. 36 minus 1 gives us 35 degrees of freedom. So that's important, because when you go to your t tables, you will need to go to the 35th row. You need to look up degrees of freedom equal to 35, and that will be the row that you use from within the tables. Now if you read across that row to the column for 2.5% in the upper tail, that's when we get the cutoff value, or the critical value, of 2.0301. As soon as we've done that, we've pretty much finished with the diagram. Really now it's just a matter of substituting in the values and then doing the number crunching on our calculator. But please don't forget, confidence intervals, they're always that same format. Point estimate plus or minus critical value times standard error. So we just need to put all of those values into our formula and then into the calculator, and we'll have our result. So point estimate, sample mean, our starting point was 75. To that we're going to add and subtract the critical value of 2.0301 times standard error. Now standard error is s over the square root of n. Our sample standard deviation s is 24. Our n, the sample size, is 36. Don't forget to work out that critical value times standard error component first. If you work that out first, you can then just add and subtract it. Now it comes to 8.1204. So we can add it on to 75 and we can subtract it from 75. And when we do that, we get the upper boundary, as well as the lower boundary. So by adding it on, we end up with 83.1204. So that's the upper boundary of our confidence interval. And if we subtract it from 75, we get 66.8796, which is our lower boundary. So at this point, I can tell you that even though we've got a sample result, our sample mean was 75, using this as the starting point and then going a little bit above and a little bit below to take into account sampling variation, I can tell you that I am 95% confident that the true population mean mu is between 66.8796 and 83.1204. So we've used our sample to say something about the population.